Hi, and welcome to this webinar with Yugabyte and Linkerd. My name is Charles, and I'll be walking you through how to integrate the YugabyteDB distributed storage with Linkerd service mesh in order to get meaningful metrics that you can use for your distributed storage database. So today, we'll take a look at what a service mesh is. We'll look at what distributed storage is with Yugabyte, and we will also go through a quick demo, and I'll show you how to deploy Linkerd to your Kubernetes cluster where YugabyteDB is running. So let's start with the distributed storage with Yugabyte. What is distributed storage and why are we here today? There was a blog post that was written by Bhavin Ghandi who talks about using Linkerd with YugabyteDB to gain to secure the connections between your instances in the YugabyteDB cluster. So we'll have to take a step back and understand what that means within the context of distributed storage. But the main reason that we're talking about this today is to show you that when you have a distributed system with separate workloads that are communicating across the network, regardless of what those type of workloads are, you can use a service mesh to gain security and actionable metrics, as well as some other features for those workloads. In this specific case, in this blog post, Bhavin talks about how he deployed the YugabyteDB demo application with YugabyteDB itself, and then added Linkerd to it. So I'm going to expand on that because he talks mostly about the security of the connections, which I'll touch on as well. And I'm going to show you how you can get metrics about those connections from between the instances in the database. So our architecture looks like this. For a distributed storage system, you typically have an application front end or an API front end that interacts with the database. In this clustered architecture, you have the Yugabyte master and a Yugabyte T server. Oftentimes, the T server is used for replication. And in this case, I've set up the example so that the front end can communicate with the T server. Usually, you would do this in a read mode only. This is a bit of an advanced topic, but it's very common also to have the front end talk only or communicate only with the master instance. You can also see that the master instance communicates with the T server instance because it's doing replication and sending data to those instances. And the main reason for this, there are a number of reasons for having a distributed system, including distributed storage. And for Yugabyte, those advantages, the reasons for doing that are to gain developer agility so that you can have multiple instances of a database where developers can access data at whatever level they need to. So if they need to access staging data, they can do that. If they need to access production data, they can do that as well. Usually you would only do that in a read mode only though. You can operate resilient services. So what we mean, this is one of the key concepts of the service mesh of Linkerd. And when we talk about resilient services, we're talking about services that if there's an outage or a failure, those services will remain available, they'll remain active, and the application continues to function seamlessly. You can also scale on demand. Low user latency is another benefit to using a distributed system like YugabyteDB. What this does is because you've got these systems that are distributed, you have to ask yourself, where are they distributed? And so oftentimes we distribute these systems globally. And so if you've got a user in Europe or in Asia who is accessing data that is centralized, well, this data is now decentralized. And so when they make that request, they can pull data from an instance of YugabyteDB that is in their region, which makes that request and response much faster. And as we know, makes users happier. The distributed systems also, or distributed architecture also allows for Yugabyte to embrace multi-cloud architectures. And so again, going along with the theme of working in different regions, if a cloud provider like AWS is not available in a region like Asia, then in order to accomplish this distributed system, you need to be able to use multiple clouds. And so let's say you're using Alibaba Cloud and AWS, you can distribute YugabyteDB to each of those clouds without having to make any special configurations or to worry about whether they're going to be compatible when they are replicating or communicating with each other. And finally, YugabyteDB is an open source project, which is close to my heart, as we'll see with Linkerd, which is also an open source project. You get the power of contributors from all around the world who are working with you in collaboration to write code to make YugabyteDB better, more resilient, more agile, to be able to scale in different ways. So those are just a few of the advantages of using YugabyteDB and having a distributed storage. Let's start to dive into what that looks like in practice. What we're going to end up building by the end of this talk is what we see here. So if we take a look at the original architecture, distributed storage, we have our app front end that's communicating directly with replicas of the master and T server databases. When we look at adding a service mesh to this, Linkerd specifically, what is happening is these instances are no longer communicating directly with each other. They're communicating through these proxies. And that's really the power of the service mesh. It is tying all of these services together. And by doing so, it can begin to collect those metrics. And as Bhavin mentioned in his blog post, we can secure those connections as well. And that's really powerful. We see this used a lot for regulated environments like telcos and banks, and also companies like if you consider some of the more popular chat applications that have end-to-end encryption, this is very important for them as well. So this is what we're going to end up building by the end of this. So let's take a look at the service mesh. Linkerd is the first service mesh. It is the application or the software that coined the term service mesh. And so let's take a look at what that offers. This should look similar to what I was showing you with the distributed database. This is a more abstracted version of that. So when we talk about a service mesh, we're still talking about distributed applications. And when Linkerd was initially created, we were looking largely at HTTP and gRPC traffic. And so when you take this very abstract design of an application, you see that you get requests coming from internet users, whether, again, it could be an API or it could be an actual user, somebody who is making requests from their mobile device. And they send a request to service A, and services A, B, and C all communicate with each other. In a real world application, what we see is much more than just a simple A, B, C service talking to each other. What we have is application that gets user traffic, and you have multiple services, especially when we're talking about a microservices environment. So in this case, in a real world application, we see multiple services that are communicating with each other. Some of these services may be communicating with a database like YugabyteDB. Other services may be communicating to external APIs. And so you can see that very quickly, this becomes a complex environment. But there's no reason to be scared of a complex environment, because this is where things become very powerful. So in a real world application, we have a lot of services that are talking to each other. And not only do we have a lot of distinct services talking to each other, we have multiple instances of those services talking to each other. So I'll show you, when we get into the demo, I'll show you what that looks like for YugabyteDB specifically. So let's go back. We'll go back to our simple architecture of just services A, B, and C talking to each other to help explain concepts of a service mesh and why it's powerful. This, again, should look familiar to the diagram that I showed you about building what YugabyteDB is going to look like once we've integrated Linkerd with it. What we have is called the data plane. So the service mesh is comprised of the data plane and the control plane. The data plane is for Linkerd specifically is many very small, fast, what we call micro proxies. And so this is a proxy that's custom built. It's built specifically for Linkerd. It's called the Linkerd 2 proxy. And it is written in Rust so that it is memory safe and type safe, very fast. So this proxy is very robust. It's purpose built. Some of you may have heard of Envoy, which is a proxy, a general purpose proxy. The Linkerd proxy, in order to be highly performant, is purpose built for the Linkerd service mesh. So bring this back to the data plane. In a typical environment, Kubernetes application, where Linkerd is injected into the services, you can see that this data plane can be as large or as small as you want it to. The control plane, on the other hand, is a set of 5 or 7 components, depending on how it's installed, that are used to interact with the proxies in the data plane. So what I mean by that is what we'll see is when we inject the Linkerd proxy into a YugabyteDB instance, what's going to happen is the control plane is going to look for an annotation on the namespace, which I'll show you, it could be on the namespace or on the deployment, or in this case, we use stateful sets and deployments. And so when the control plane sees that this annotation exists, there are additional components that will automatically add the YAML for the Linkerd proxy into the deployment or the pod for the workload. So the goal here is to make it easy for you to deploy the service mesh without having to do a ton of configuration, and to be able to get up and running very quickly. And that's what we're going to show you in the demo today. And I'll show you each of the components in the control plane as we go through that. The other thing the control plane does is issue certificates. In Bhavin's blog post, he talked about the mutual TLS, which is the communication between these services, and how and I mentioned that that's encrypted. And so the control plane includes a component that is an identity component. And what that does is it issues certificates to the proxies so that they can communicate using mutual TLS. And so mutual TLS is an important part of security in an environment where, like if you have a multi-tenant environment where you have multiple users in the same space, you want to be able to encrypt the traffic between your services so that anybody who's on the network can't listen to that traffic. So we'll see how that works. Before we do that, let's take a look at the other aspects of what makes a service mesh a service mesh. For Linkerd, there are 4 main pillars, 4 main concepts of a service mesh. One is observability, and that's what we're going to focus on today. This is what we're building on from Bhavin's blog post. Security is what Bhavin was talking about in his blog post. And so I encourage you to read that. You'll see how Linkerd secures the traffic between these services. And I'll do a quick to show you exactly what he was talking about in this example. Reliability talks about how ensuring the services are available, and this again ties into that concept of resilience. So you can equate in some cases resilience and reliability. The way Linkerd enforces reliability is by ensuring through load balancing and through retries and through timeouts. So this is specifically for HTTP traffic. And so Linkerd focuses on those 3 to ensure that an application remains available, up and running, and that really the power in load balancing is making sure that no single service is overwhelmed, and so that response times remain consistent across from a very high level overview of overall response times. And finally, we talk about traffic management, and this is powerful for a distributed system like YugabyteDB as well, because what this enables us to do is split traffic to different versions of services. And so even if you have like different versions of database. We talked about developer agility. If you want to be able to route developer traffic to a staging environment, that's possible to do with Linkerd. So these are the 4 pieces to a service mesh, or specifically for Linkerd, these are the 4 key concepts that we talk about. When we talk about observability, which is what we're going to talk about today, we talk about the rich traffic metrics. These are actionable metrics. In the Google SRE book, they're called the golden metrics, which are request rate, success rate, latency. It's across many dimensions. This is for HTTP traffic. For TCP traffic like Yugabyte, we'll be able to see TCP level metrics like the number of bytes read and written and the number of TCP connections opened and closed. The security piece, again, is all part of Bhavin's blog, but we talked about mutual TLS, and the important thing with mutual TLS isn't just the encryption. Actually, the more important piece with mutual TLS is the validation between the services. And then after that, you get the encryption, which, as I mentioned, is also extremely important depending on the use case. But in my opinion, the validation part is the overlooked part of mutual TLS. The reliability piece I mentioned, we've got latency aware load balancing using that EWMA, estimated weighted moving average algorithm. And then we have retries and timeouts, again, for HTTP traffic. And then the traffic management is the traffic split that I talked about. A simple example of this here is you have traffic that comes in through the ingress. The traffic is routed to service A, but service A is configured in such a way, and this is where the traffic split comes in, so that if you have 2 versions of service A, let's say you're running a blue-green or a canary deployment, version 1 is the current version that's in production, you're ready to roll out version 2, you can slowly migrate like 1%, 2%, 10% of the traffic to version 2, while you're observing version 2 for any errors or any performance behaviors that are undesirable. And then once you've determined that it meets all the criteria, you can push all 100% of the traffic over to version 2. So this is one of the powerful things that Linkerd can do as part of the service mesh. Okay, let's talk about the demo that we're going to do. So I'm about to jump into the demo, and what we'll see is I've got the Yugabyte demo apps and Yugabyte master and Yugabyte T server. And so when the Yugabyte demo apps is actually generating the traffic, and it's going to be injected with the Linkerd proxy, and it's going to be sending traffic to the Yugabyte master and Yugabyte T server instances. So we'll see all of this in the Linkerd service mesh. And this is following Bhavin's blog post. So what I've done is I've already set up YugabyteDB. I'll show you that the pods are running, they're not injected. Linkerd is not installed in this cluster, but what I will be doing is installing Linkerd in the cluster and as part of the demo, and we'll see the secure connections, and I'll show you the read and written bytes for the TCP traffic. So with that, I think we're ready to jump in. So we'll hop over to the terminal. So we can see all the pods in my cluster. The main ones that we want to look at right now are the Yugabyte demo. We see that for the deployment, this is our load generator. There's 1 container and it's up and running. And for each of the YugabyteDB instances, there are 2 containers, both up and running. We'll see how Linkerd affects those. I'm going to scroll up briefly here so that you can see that Linkerd is not installed. Oops, that works too. Okay. So with that, what we're going to do is take a look at some of the features of the Linkerd CLI. Very quickly, what I can do is I've already downloaded the Linkerd CLI. All of this is in the docs on the linkerd.io website. So if I do Linkerd version, and this should look very familiar if you've used kubectl before, because Linkerd, the CLI, is designed to work like kubectl. Here we see that the client version is this Edge version, which was just released recently, and the server version is unavailable. We release, just on a note on that, we release Edge versions about once a week. So this is 2021, the first month, the second release. So this was just released, and I'm using this because why not? It's fun. So next, what I'm going to do is run a pre-flight check to make sure that I have the right permissions to install Linkerd on the cluster. And the important thing is that everything is green checks. As you try this out, you can see that the things that we look for are being able to communicate with the Kubernetes API and really being able to create all of these resources. So Linkerd only has 2 custom resource definitions. Everything else is specifically Kubernetes, and intentionally Linkerd was designed this way to make reuse of as many Kubernetes resources as possible. So we need to be able to make sure that we can create the secrets, the cron jobs, the config maps, all those things that we need to run the control plane. So everything looks good. I'm going to save myself a bit of typing. Actually, you know, we don't need to do that. I mentioned earlier that I was going to use my own certificates, but I'm not. I'm just going to show you how this works. So what we're going to do is Linkerd install, and we're going to install it in HA mode, which means that there are multiple replicas of the control plane components installed. And if I do that, what I get is just a bunch of YAML, and that's okay. Because we don't want the client to install things without you knowing about it. So once you've verified, and I encourage you to pipe this to a file and be able to, so you can read it. Once you verified that this is something that you want on your cluster, which I assure you it is, you can pipe it to kube control apply. Oops, that's why I have shortcuts, or aliases, so that I don't have to type all these things. And once I do that, I'm going to see that all these resources are being created in the Linkerd namespace. So once this is done, we'll take a look at all the pods in the cluster again. You'll see that there's a new namespace called Linkerd, and we can see that these pods are beginning to run. You'll notice that there was a Linkerd check command before, and I used the preflight flag to make sure that I could install things on the cluster. Now that I know that Linkerd is installed, I can run just Linkerd check without that flag. And what it's going to do is go through and make sure that all of the components are running and they're healthy. And it checks to make sure that the certificates are valid. Here's the identity component that I mentioned to you. So while that's starting up, let's look at the components in the control plane. So remember, I'm in HA mode, which means I have 3 replicas of each of the components. There are actually 3, 4, 5 components to the Linkerd control plane, and they are the controller, the destination service, which is responsible for creating endpoints to route the traffic from the proxies, the proxy injector, which actually injects the proxy into the workloads, and I'll show you how we do that next, and again, that identity component that issues the certificates. So let's see if we've got Linkerd check passing. Should be by now. Yep, everything is good. Okay, so I've got Linkerd installed. I'm also going to install our viz component, which gives us the visibility into, it gives us our dashboard basically. And so I'm going to do that, and I'll leave it to you to find out what this does, but it's installing a web UI and what we call the tap component so that we can look at these real-time metrics coming through. So I'm going to do that. And then what I need to do is jump into some of the Yugabyte configurations that we have running. So let's see, I'm in the Yugabyte demo namespace. So if I look at the logs for this pod, what we see, a ton of failures. Wasn't expecting that. Okay, duplicate key, right, okay, that's okay. What I need to do is I'm going to restart this pod. Actually, you know what I'm going to do? Let's look at the namespace. So you mentioned earlier that Linkerd is automatic. The control plane automatically injects a proxy into the namespace or into the workloads through an annotation. So let's look at the Yugabyte demo namespace. And what I'll show you, you'll see that I've already added this linkerd.io.inject enabled there. What that's going to do for us is there is in the control plane, there's a mutating webhook controller. So whenever a new pod it starts of that instance of that database, then the proxy is injected in there. And that's why I wanted to show you the number of containers in each of these. So what we'll do is if I do cube control rollout, restart stateful sets, that's going to restart the T server and master instances. So this is going to take a bit of time because stateful sets roll very slowly. I didn't configure them to restart concurrently. So we'll see that it's terminating. And I know we're running short on time here. So the next thing that we'll see is that the once the new instance of both T server and master start up, what we'll see is that there's going to be 3 containers, and one of those containers is the Linkerd proxy. So let's just do this quickly. So if I do, let's look at the YAML for this pod. What we see here is that in addition to, we'll scroll up to the containers. Let's find that. There we go, containers. So we've got the Yugabyte T server. That's one container. Then we've got, I have to be careful. Oh, here we go. Yugabyte T. So wait, that's the one that I just saw. Right. Yeah, Yugabyte T server. And then we've got BusyBox, which is the second Yugabyte instance. And then we have the Linkerd proxy, and here's the configuration for the Linkerd proxy. You can see that the YAML is pretty big, but you can also see that we didn't have to do anything to add it other than annotate that namespace. And so you can annotate a namespace, you can annotate a workload or deployment, a stateful set, a pod. Any of the Kubernetes resources can be annotated and the proxy YAML will be injected in there. So that's one of the ways that Linkerd seeks to make this simple and easy for you. So let's take a look at our pods. Okay, so we're almost got them all rolled. I'm gonna restart the deployment. So that should happen very quickly. Yeah, we see already the pods initializing and we've got 2 containers in there as well. I expect that we'll see those same errors because they're duplicate key errors. But if we look at the logs and I just do this, it's going to say, hey, whoops, did I do the wrong one? I did the wrong one. There we go. I got the wrong ID there. Okay. Okay, so if we look at this, it's going to say, hey, pick a container that you want to get the logs from, and we can see that the Linkerd proxy is in there, which is super cool. We also have the Yugabyte demo apps, so let's just see if we are getting those errors. I think we probably are, but we'll see. Oh, nope, it's starting up. Perfect, this is what we want to see. So this is the traffic going from the traffic generator to the Yugabyte database. So the last thing that I'll show you is I'm going to cube control port forward service Linkerd Prometheus. Oops, I forgot to put the port on there. There we go. Let's jump over to our browser. Oops. There we go. Okay, so this is from an older instance, but so what we're going to take a look at is the TCP traffic read bytes total for all of the workloads in the Yugabyte demo namespace. And so we can see that we've got multiple workloads let's say that I wanted to just filter it down to, let's say app equals YBT server. This will make it a little more manageable. When we look at the graph, we can see a lot of traffic came in very quickly. Let's reduce, there we go. A lot of traffic coming in very quickly. And here we see that it's the instances. And so these are all, this is all the bytes read from each of the instances. And what we'll see if we continue to watch this over time is it would just continue going up to the right because this load generator is just sending a bunch of traffic over. So this gives us the TCP level metrics. One last thing that I promise, and then we can go. This is the example that Bhavin showed in his blog post. So if we do Linkerd edge -nyb demo, oops, edges, there we go. We want to look at all the pods. So if we look at all the pods, it's kind of hard to see. Let's look at stateful sets. So if we look at all the stateful sets in the Yugabyte demo namespace, we can see that there are connections between them and that they're secured. And this is secured through Linkerd. So again, if we go back and look at the pods, we can see that Linkerd Prometheus is scraping the proxies to get that data that we can see in our Prometheus instance over here, in our Prometheus dashboard. But we can also see that Yugabyte Master 0 is communicating with Yugabyte Master 2, and that connection is secure. And likewise, each of the instances of the Yugabyte distributed database are communicating with each other. So this forms a service topology for us. So with that, I will tell you, again, my name is Charles Pretzer. You can find me at linkerd.slack.io. Nope, slack.linkerd.io as Charles, and I'm always there answering questions for folks. Or you can email me directly at charles@buoyant.io if you have any questions. So again, I mentioned, like Yugabyte, Linkerd is open source. So if you want to come and join us and have questions and chat about anything as you experiment with Linkerd and Yugabyte, let us know, and I'll be there to help you out. So thanks for your time. I hope you enjoyed this, and I'll talk to you all soon.